The first test is that when the pulse width modulation 8-bit register is 0, there should be no output. The LED is 0. The second test is that I can change the pulse width modulation and it doesn't get into this latch and the output stays 0. This is because there's only one pulse width modulation 8-bit register that's sent to all the LEDs. The third test is that when I click on data, it doesn't do anything. It still says 0 because we haven't entered this set pulse width modulation. Now it sets it in here. The next test is that when the data is being set, so when the set pulse width modulation goes to 0, then we start seeing the half on, half off behavior. This is half on, half off. And when I select data to be 0, it still continues to run. If I select this, this should not change. Nothing changes. So both these have to be on in order to enable this data. And during that time period, this stops. See, now it's stopping. This sync line stops it also. But it does, in addition, it clears this register right here. So if we start playing with this clock, normally you don't want to do that because this gets into human hearing range, 20 kHz, and you'll actually start hearing things happening. The larger this number, the longer a 1 is on. So here you can see it's just blinking. If I make this number really small, well, make it 0, then it never blinks. If I make it just 1, it blinks so fast you can't even see it. Here it should be half on, half off. So I'm going to turn off this clock and manually operate it. It's counting down. When it's counting down and it sees when these match, this should go to a 1. Right? There it went to a 1. Now when this counts down to a 0, it should change back to a 0. There it goes to a 0. So we need to test those two boundaries.